Also, turns out baby has an ear infection.
Oh.
Okay, holy crap, we're live. Despite the tech gremlins' best efforts to thwart us. Um, Hi, friends. It has been half a minute. I'm so glad all of y'all are here. And I've got Dapper here with me to help me out on my show, on my first live stream back. Dapper, how are you?
Oh, I'm doing well. I feel like I haven't talked to you all summer.
All summer, right? Yeah, we weren't here, yes, to 2 days ago.
Well, no, 2 days ago it was the spring.
You're right, it was spring. Oh,
So this is the
goodness.
first
It
time I've
is
talked to you all summer, literally.
all summer, literally. Happy solstice, everyone. Um,
I went out and stared at the sun for about the minute before and then after the solstice, but I was using a
ooh,
solar filter to
uh,
stay safe.
excellent choice. Uh,
Yes.
excellent choice. Um, yeah, I've been, yes, okay, thank you guys so much for coming out. I've been gone a while. Turns out, who would have thought dissertation plus baby takes a lot of time. Um, but we're gonna try to get back to doing a live debunking stream once a month for now. Baby is perfect, by the way, if anyone was wondering. Though right this minute she has an ear infection, so if I have a bit of a frazzled look to me, it's because baby has been sick for like a week. And uh, why do the Himalayas cause the jet stream to split? It's really just because topography does an absolute nightmare on the weather patterns, right? Like the surface weather at the surface is so complicated because things get in the way. Um, Sorry, this is the comment I'm reacting to. Um, so the Himalayas are tall enough that they physically just get in the way of the jet stream. um like there are plenty of places where like the tropopause can be at the surface right. Anyway, so yeah, the Himalayas are giant, and so they can really mess with the jet stream, and it's just a physical object in the way. Anyhow, um the good news is with baby, uh we got her some antibiotics today. We thought she just had like the daycare crud, because she wasn't like grabbing at her ears. But anyway, um, am I popping again? That's no good. Okay, I'm not even gonna try to troubleshoot the Yeti. I will go to the less good mic, because I'm done with uh.
Mics are annoying.
Mhm. Okay, can you hear me?
I can hear you.
Okay, cool. We're just using the shitty mic on my headphones. Anywho, um oh, there'll be so the jet stream is at the troposphere stratosphere. It's like the jet stream is in the troposphere, right? It's kind of close to the tropopause, but it's not super 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 high up. Um anyway, yeah. And what do I think about the fun times people are having posting? I haven't seen this trend. Where are people posting sea surface temperature maps? And is that like an anti-climate change shenanigans? Anyhow, okay, but today, what we're here for, friends, Romans, countrymen, is is this. This is Venus, no greenhouse effect. I saw this like 6 months ago, and I was like, blah, I need to do a stream, but baby is little. Um, so, anywho, okay. Oh, yeah, turns out oceans are hot, right? That's what happens with climate change. It's a thing. Um,
Don't say.
I don't say. Yeah. So the goal. So if we're thinking about warm waters near Europe, right? Europe. I nerded out about this on Dapper on your channel 2 days
Mhm.
ago. Europe's temperature, specifically Western Europe's climate, is there's two there the ocean, specifically that Gulf Stream that comes up the east coast of the US and then goes over to Europe, does an amazing job at moderating Europe's temperature. So specifically Western Europe. And so what it does is it keeps Western Europe cool in the summer and warm in the winter. That's because ocean water, so ocean water in general is about 3 months behind in temperature from the atmosphere, right? So like right now, oceans think it's like March, right? And that's because it just takes of the heat capacity of water, it takes longer to change the temperature. And so if you're bringing in that sort of cooler surface, right, over towards Europe, then air is going to move over that cool surface and then bring in cooler air over the European continent, over like that Western Europe, which keeps their summers much more mild. And then it's the opposite in the winter. The ocean is warm relative to the land, blah, blah, blah. But yeah, but as the planet warms up, the oceans warm up too. Turns out that's a thing that happens. And so, yeah, I'm not surprised that like the Gulf Stream, that current is warmer than it sort of should be, or it's warmer than it has been in the past, which basically means that Europe isn't going to get that much of a benefit. So that would lead to like heat waves in Europe over the summer. So if we've got folks in here, or folks over there, and they need help on how to prepare for a heat wave, and they don't have like central heat and air, swamp coolers are great, but buy your ice from somewhere else.
Yeah, if you make it yourself, you're just making the house hotter.
Yeah, because the net energy.
Mm-hmm. It turns out that freezers are not perpetual energy machines, believe it or not.
Believe it or not, they are not.
Who'd have thunk?
Who'd have thunk that? So anyway.
Now, I will say, if you have a bathing suit with pockets, like a men's bathing suit, putting some ice in the pockets, even if you're making it at home, it can cool off you personally enough that it's probably not too bad that you're slightly increasing the temperature of your house by like making a couple ice cubes every few hours.
Yeah. Also, a good thing to do is get your ice and put salt on it, or like rubbing alcohol, because both of those will drop the temperature of the ice. It'll make it much cooler and nicer. And if you've got a cellar, hang out in your cellar. That's a great place to beat a heat wave.
Did I ever tell you the can of Coke and salt and ice story from when I was in the Navy?
Yes, you did, but tell it again.
All right, so we weren't very happy with how cold the sodas were by the time they were getting down to, the engine room, basically. Because, we had some roving watches who were allowed occasionally to leave the plant. And one of the things they would do is, they'd collect everyone's little money chip and go grab them whatever soda they wanted. And so, okay, but we weren't very happy with how warm they were. So we concocted this plan where we're going to get the ice from the mess decks, put it in a bucket, steal a bunch of salt shakers from the mess decks, put the salt in there, put the cans of like cola, mostly just Coke, in there, right? But we put so much ice and so much salt that it froze the cola, and so there was this concentrated syrup in the middle, surrounded by slushy ice in the cans.
Oh, beautiful.
It was very cold.
Yeah.
And hey, you know what? When you're in the middle of the Persian Gulf, that's okay.
That's okay. When you're in a giant metal thing in the engine room in the middle of the Persian Gulf, absolutely.
Oh, yeah.
So I found this team, and it's a blog, and it's so Irate, right? It's so like my brain's so big, energy, which is going to try to explain to us why Venus, in fact, proves that there is no greenhouse effect.
Makes lots of sense.
Yeah, it makes so much sense.
Yeah.
So we're going to read through this, and it's so up its own ass is what it is.
This feels like using like the space shuttle to prove that heavier than air flying machines don't happen.
Right. Yeah. So, okay. So I'm gonna start reading, and we're gonna read this opening paragraph, and it's just dripping with Fedora. The flip side of the entrenched incompetence in science today is that all it takes is scientific competence to make revolutionary discoveries or fundamental corrections to correct dogma.
The current dogma.
To current dogma. Excuse me. I got too into my character.
It's okay.
Being a competent physicist rather than an incompetent climate scientist, which 97% of them demonstrably are.
That's big, if true.
Yeah, that's a reference to there was that 97% of climate scientists agree that the Earth is warming and it's people's fault, right?
Ah, yes.
That's what that number comes from a study that was it was like a macro study where they looked at like authors of papers, right?
Mm-hmm.
And anyway, that they didn't like ask every climate scientist. They looked at like the positions held in scientific papers.
Which, I mean, unless you've retracted a paper, then you should probably stand by it.
Yeah.
Or unless you've later published something that contradicts your previous claim. Then,
So I was able to recently post an answer on yahoo.com, noted amazing science journal.
Wow.
To a question about the greenhouse effect on Venus, to which I give here.
This is being like, yeah, well, I told someone on Quora that the science is wrong. Like, oh, okay.
Yeah. That's like, isn't Jordan Peterson's, like, his whole 12 habits, whatever?
12 rules or something?
12 rules. That started as, like, Quora, right?
I mean, it might have. You might not know this about me, Maddie, but I do not actually spend a whole lot of time thinking about or reading about
Jordan Peterson.
Yeah, I just don't.
That's fair. That's fair. I find him... Well, okay, I sometimes rage watch, like people snarking on, like, Peterson, Matt Walsh, and who else? Like, stupid anti-feminist people, right?
Mm-hmm.
Anyway. And I get joy out of them being demonstrated to be idiots.
Although, from what I've seen of his 12 rules or whatever,
yeah.
Most of them are just like, hey, like, keep your appointments, stand up straight, clean your room. And it's just like, okay, none of that's like horrible advice or anything.
It's not, but did you need to buy a book to learn that?
Some people might.
Okay, that's fair. That's fair. Okay. So this blog post here is an update to his answer about what about the greenhouse effect on Venus. We're not going to go to whatever the original yahoo.com question was. Surprisingly to most, there is no greenhouse effect at all, and you can prove it for yourself. So before we go any further, let's chat about fundamentally what is the greenhouse effect, right?
Oh, can I attempt to give my estimation to see how good it is? Because this is not an area that I spend a lot of time in. So
yeah,
So my understanding is that the greenhouse effect is that basically there are certain chemicals which are good at absorbing certain wavelengths of electromagnetic radiation. And that as a result of that, they will, if they are more prevalent in, say, the atmosphere, they will absorb more of this wavelength. And of course, that translates directly into thermal energy, which then, if they are absorbing this electromagnetic radiation faster than the Earth radiates it back into space, because, that's a thing that Earth does. Radiative cooling is a real thing. Then that means that the Earth, or the Earth, if we're talking about the Earth or Venus in the case of Venus, will tend to get hotter over time until the equilibrium is reached. Because, of course, as you get hotter, you do start to radiate faster. So if you were to say, just up the amount of those chemicals by, say, like 10% and leave it, eventually you get to a new higher temperature. But what we're doing currently is continuing to add more, pushing that equilibrium temperature both higher and further into the future.
Yeah, absolutely. Yeah, that's a really great explanation. The only one thing I want to add is like, so the very, very, very basics of this, right, is that every atom or molecule in the universe, right, anything that has electrons will absorb energy, right, that's related to the energy state of their electrons. This is how lasers work, right? You excite an electron and then it falls back down, and every time it falls down, it emits a photon with that exact amount of energy, right?
Now just to figure out how sharks work so I can put the laser beams on the sharks.
Exactly. So this is just what wavelengths of electromagnetic radiation a molecule absorbs is just a physical property of that molecule, right? And then the other thing that's important is that the sun emits this all bodies are emitting electromagnetic radiation sort of technically like in all wavelengths, but it follows like it's got a peak, right? So
black body radiation.
Black body radiation. I actually have a video explaining how that works in my like in my climate dynamics series on my channel. Anyway, if you want more detail. But the sun's peak wavelength is in the like visual to ultraviolet. It actually in fact it peaks at yellow. That's why it looks yellow when we look at it, right? Jack of Hearts says, Maddie, I understand that electron falling because I studied chemistry, but I don't think that explanation was layman enough, LOL. I'm going to assume that was sarcasm. You guys remember, you've got to tell me if you're being sarcastic, because I don't. You got to do this /S or else I don't understand it. So I think that was sarcasm. Anywho, okay, but the Earth emits predominantly in the infrared, right? Which is, in fact, why when you look down at the ground, you don't see visible light.
If you could, it would mean the Earth was hot enough to be red hot or hotter, which would be bad.
That would be so bad.
That's literally what red hot is getting it just into the visible part of the spectrum in terms of your peak emission for your black body radiation.
Yeah. And so gases that we call greenhouse gases are ones that absorb in the infrared, right? So carbon dioxide, carbon monoxide, right? Those are two of the very common ones. Even water, right? Water vapor is good at this. Does not absorb the energy that comes from the sun, right? It's not good at doing that. So we like to say a simplified way to look at our atmosphere is that the Earth's atmosphere is transparent to the solar radiation, right? But lucent, or even it's not opaque, right? But so the incoming radiation from the sun comes in, gets to the Earth absorbs that, and then re-emits that back up. But when it's re-emitting that in the infrared, now these gases absorb and re-emit that. And as little old carbon dioxide atom, it absorbs radiation and then it re-emits it in all directions. So half of that energy goes back to Earth, right? And then the other half leaves to space, right? This is kind of the simplified picture. And so when people say the greenhouse effect isn't real, right? I need you to explain to me what part of this is your argument that carbon dioxide, like, is it that the Earth doesn't emit in the IR? Is it that carbon dioxide and carbon monoxide and water vapor don't absorb in the IR, right? Is it that black body radiation doesn't exist? It's
Maybe it's that greenhouse gases preferentially emit IR away from Earth.
ooh, that would be handy. But like that's what the greenhouse effect is, right?
Yeah.
That's what it is. So I don't really know how you can say that it's like not real, right?
Yeah. Like every step is basically like high school level physics.
Yeah, it's really basic. It's all stuff you can just measure, you know?
Yeah, that's actually a point I've made is like you can go into a lab and test the greenhouse effect of various chemicals. You don't have to guess about it, right? Like you can just tell, oh, hey, what, peak wavelength for absorption or what, characteristic wavelengths does this chemical absorb? Oh, it's in the infrared? Okay, well, guess what then?
Guess what? It's going to emit in the infrared, and
Yup.
it's half of it goes back down, and so that's adding energy back to the Earth. We recycle some of that energy.
Hey, fun fact: absorption and emission spectra have the same wavelengths. They're just that's just how they work.
That's just how it works. Okay, so that's what the greenhouse effect is. Let's see how Venus proves that it doesn't exist.
Good luck.
Okay, from the temperature and pressure profiles for the Venusian?
Yeah, Venusian.
I guess I always want to pronounce it like it's Venice. Like I want to say Venetian, but
no, that's a different word.
That's a different word. Okay.
Because there's a U in Venusian.
Venusian atmosphere. You can confirm that the altitude at which pressure is 1,000 millibars, which is roughly surface pressure here on Earth. It's like the actual average surface pressure is like 1,013 millibars.
I'd say that's close enough.
Yeah, which is the sea level pressure of Earth. The temperature of the Venusian atmosphere is 66 degrees Celsius or 339 Kelvin.
I'm happy he at least knew enough not to put the little degree mark after the 339.
That is helpful.
Yeah.
So he says, this is much warmer than the temperature at the surface of the Earth.
Okay.
Which is about 15 degrees Celsius or 288 Kelvin. That is true. That is like average surface temperature. That's a good number. Jack of Hearts, you're totally good, man. I just I get a little embarrassed when I can't tell if people are being sarcastic. Which is always. And look, guys, the guys in my Navy division they would bang their wedding rings on the table on their desks to let me know when they were being sarcastic. And now my husband does that, and it's very helpful. Anyway. Okay. So he's going to say, however, Venus is closer to the sun and gets proportionally more power from it. Earth is 93 million miles from the sun on average, while Venus is only 67.25 million. Since the intensity of the sun's radiation decreases with distance from it as 1 over r squared, Venus receives ratio 1.91 times the power per unit area Earth receives on average. I'm pretty sure that's a good number.
I believe it is.
Yeah, I'm not gonna like plug that into the calculator, but
I will say if you're trying to overturn science, maybe use kilometers.
Yeah, that's fair.
Or in this case, since we're talking about astronomical distances within the solar system, you could use the AU.
Yeah, Earth is 1 AU. Venus is slightly less than 1 AU.
Yeah. I think it's like about 2/3 or something of an AU, something like that.
Yeah. Okay, so does it? Yeah, okay, so yeah. This that r squared, that's like related to if you think of the energy coming off of the sun as like an expanding sphere, right? The total energy is shared over the surface area of that sphere, which is proportional to the radius of that sphere squared.
Yeah.
And so that's where he's getting that relationship. So that's...
I like to think of it as like there's a grid of photons. And as you increase the radius of the grid, right, then the spacing between all the photons on the grid has to become bigger, but not linearly. It has to go up by a square because that's how the square for like radius versus volume work, or not volume, but surface area kind of thing works. Yeah.
I love that. That would be a really cool animation, like 80s style sci-fi. Boom, 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 right?
I mean, I could definitely do that.
See the photons moving out. That's a great way of thinking about it, that right?
Thank you.
Okay. So I'm pretty sure that 1.91 should be fine. Like I don't have a problem with that number, and that the setup is right, and so I'm gonna trust that.
I already have a big problem with where we're going, which is basically hey, Mercury's even closer, and it's colder on average than Venus.
It is. He doesn't bring that up remarkably.
Oh, you don't say.
I don't say.
Yeah. Wow. Weird that.
So, okay. Oh my god. Okay, it's thundering outside too. I'm gonna lose my mind. Guys, I cannot express to you. Hold on. Sidebar moment. I cannot express to you how many things we're trying to prevent this live stream from happening. One, as of yesterday, I had fully lost my voice because I have a cold. And I also have not been sleeping. I'm a little crazy right now because baby has an ear infection. And so baby doesn't sleep. And because she also has been sick and bringing home colds from daycare, she's been sharing those with me and my husband. So nice of her. So good at sharing. And there's that. There's a thunderstorm today. So I'm going to die laughing if my power goes out. Chrome decided that it didn't want to play with StreamYard anymore, and I was still troubleshooting at like 8:05. I don't know what else has gone wrong, but anyway.
I was just sitting quietly like, I wonder when Maddie's getting here.
Yeah. I was like, I'm restarting my computer. It's fine. Yeah. Anyway, okay, there we go. That's my sidebar moment. And why I'm a little insane. I've been a little insane for a year because turns out when you have a newborn, you don't sleep.
This is true.
She started going to daycare about a month ago, and the first week I didn't even try to do work on my dissertation. I just slept, right? I just caught up on sleep and was like, what have I been like for the last 9 months? Okay. All right. Back to this. Okay. So, since the radiating temperature, excuse me, I'm not in my milady voice. Since the radiating temperature of an isolated body in space varies as the fourth root of the power incident upon it by the Stefan Boltzmann law, the radiating temperature of Venus should be the fourth root of 1.91, 1.176 times that of Earth. So funnily enough, so what he's doing is just the straight up black body. So this is all true if Venus and Earth don't have atmospheres.
Now, remind me.
Mm-hmm.
Venus, I feel like whenever people take pictures of it, they can't really see the surface, and they had to send like some kind of weird like radar satellite or something to get like a topographic map. Now, is that because Venus lacks an atmosphere entirely?
No, and remarkably, Dapper, I don't think this is brought up in this article, but are you aware that the density of Venus's atmosphere is roughly 100 times that of Earth's?
I probably couldn't have quoted that number to you, but I would have said many times that of Earth if asked. So,
and surprisingly, Mercury. Oh, actually, this is really cool. We always thought Mercury didn't have an atmosphere because it's like too small, and Jean's escape would have allowed any atmosphere that was there at formation to have escaped, just because gravity isn't strong enough to hold those individual atoms. But oh no, what was the mission where there was that orbited, it got a few orbits around Mercury, and it started with an M, and it happened in like 2011. Anyway, NASA did a cool thing, and they discovered that Mercury actually has a very thin sodium-based atmosphere, which is super cool.
So you're saying that Mercury smells like rotten eggs?
Mercury smells like rotten eggs. No, sodium, not sulfur.
Oh, right, sodium. So it smells
Yeah.
like a salt water.
Yes. Savage Cobra official per se says, "Oh yes, Messenger. Absolutely, it's the Messenger mission. Thank
That's
you."
an M, not an N. I was thinking of M. I
Oh,
wouldn't have
I'm
thought of
sorry.
messenger either.
I said
worry.
M. Also,
Oh.
sarcasm. Venus doesn't have an atmosphere. It just has several quadrillion rubber ducks in close orbit. Love that.
There we go.
That explains everything.
New headcanon right there.
Yes. Anyway, okay. So so he's just doing the straight up black body calculation,
which is not how this works.
Which is not how this works. And again, this ignores the effect of atmosphere, because if the Earth without the greenhouse effect, spoilers, Earth would be fully uninhabitable because it would be a frozen, lifeless rock.
The thing is, you could set up at home a pretty easy experiment to demonstrate whether or not this works, right?
Yeah.
Like, all you would really need is, the black plastic that they make trash bags out of?
Yes.
Fun fact, while that is very opaque to visible light, it is essentially completely clear to IR light.
Yeah.
So, if you had, say, a vacuum chamber, right?
Mm-hmm.
And you were to, say, put a rock in there, and then cover that with some of that trash bag so that other light sources can't get in, but you can look in with, say, a infrared camera, which again you can just purchase.
Yeah.
You could see, okay, given a certain light, like heat source, right? Like you could just have a standard whatever watt light bulb, which puts out a lot of IR radiation.
Yep.
Shine on it for a certain amount of time. Then you could do it again after having pumped in some CO2. And how do you get some CO2? You can just buy some dry ice and then put it in there and wait for it to reach thermal equilibrium.
Yeah.
Then bring in the light bulb, use your camera, and hey, is the rock hotter with the CO2 or with the vacuum? I'm pretty sure you'll find that it's hotter with the CO2 atmosphere than with the no atmosphere. And because you isolated basically all wavelengths of light except IR, you're really, really getting into that IR level of causality there. It's it's sad that I could design an experiment that would at least give you approximate results for this.
Yeah.
And this guy's just like, yeah, but what if I just ignore atmospheres and do math? Like,
yeah, because
okay.
I'm a competent physicist.
Who doesn't know about gases?
Or density.
Or density, yeah. Or, just optical properties of things that exist.
Yeah. Okay. All right. So that's, he's saying that 1.176 times that of Earth. Okay. Furthermore, since the temperature at any given pressure level within the Venusian atmosphere should be 1.176 times the temperature at the same pressure level in the Earth atmosphere, independent of the different levels of infrared absorption in the two atmospheres. In particular, the average temperature at 1,000 millibars on Earth is about 288 Kelvin. So the corresponding temperature on Venus, without any greenhouse effect, should be 1.176 times that, or 339 Kelvin. But this is just 66 Celsius, the temperature we actually find there from the temperature and pressure profiles for Venus.
Now, I have a question. Isn't this also assuming that both bodies are perfect black bodies?
Yes.
Now, okay, I know it's dark at night. Right? Or just, but I feel like I've seen light reflect off of the Earth even at night.
Turns out it does, yeah.
Okay, now, my recollection is that a perfect black body reflects literally zero electromagnetic radiation.
That is true.
Okay, I also seem to remember that among planets, Venus actually has a fairly high albedo because of its dense cloud cover.
Sure does.
So, even if we ignored the effects of the atmosphere, like he's doing here, wouldn't we also then have to pretend that both of them had an albedo of like
1.
0.
0, yes.
Yeah.
Gosh, sorry, I always flip what the alpha number is.
Nah, it's all right.
Yeah.
But my understanding is that neither body has an albedo of 0. In fact, they both have fairly high albedos.
Right.
Huh.
Yeah, so yeah, we have an albedo of, we reflect 30% of light away. I'm going to flip it backwards
So
in my
that's
head.
0.3.
And so, but here's the thing, if we're looking at heat exchange between layers of the atmosphere, which is what he's trying to compare, right?
Mhm.
He's trying to say this layer and this layer, then you can't use, you can use straight black body math, but you have to do, it's, okay, so you have the surface of the planet is a black body that interacts with the first layer of the atmosphere, and that's a black body that interacts with the second layer of the atmosphere, and that's a black, right? You got to do that. And so to do, so like, so this doesn't work, right? This doesn't work. And also I don't like, how do I put this? The density difference matters. Venus isn't like the fact that that number works out is happenstance, right? And perhaps somewhat contrived. And anyway, let's keep reading. Because I think he has more to say. And it also claims that then every level should have this, every pressure level should have this exact relationship. Well, anyway, and then that means that temperature in the atmosphere is only controlled by the change in pressure, but these two guys have different densities, right? Different average densities. And if you're looking at the temperature of the whole column, that change in density matters because it goes to 0 at the top of the atmosphere.
Mm-hmm.
Anyway, all right. So there is no greenhouse effect. You have just proved that climate science is utterly wrong to think otherwise. This is the scandal that so many experts in climate science and all the scientific authorities will not face. Listen to the physicists that tell you there is no greenhouse effect. They know.
Oh, sorry.
They know without having to go to the Venus data, and I am one of them. I'm definitely a physicist and not just a keyboard warrior. The continuing incompetence on this vital point among so many scientists for more than a century is amazing and tragic.
Okay, so let me see if I can understand what this guy is trying to say here. Make other predictions about this, right?
Yeah.
So he is trying to make the claim that the only thing that should affect the temperature of two similarly sized bodies is the amount of incident radiation on them. So that should mean that if I build an actual greenhouse with glass, panes, and whatnot, and then next to it build a concrete and insulation building, that the temperature inside my concrete and, like, say, foam insulation building should always be the same within a very small margin if it's the same size and shape as this temperature inside my greenhouse. I feel like people build greenhouses specifically because that isn't the case.
Yeah, it turns out.
Okay, I just wanted to check with all that. Like, this, because, hey, you know what? Maybe I'm dumb. Maybe I don't know. Maybe greenhouses are actually just fake and they don't really exist. I don't remember ever having actually been to one in real life. So
yeah, but were you there?
I wasn't. That's the thing. That's why I'm double checking.
Yeah.
Okay. So
okay,
just the very existence of the object called a greenhouse.
A greenhouse that can't exist actually.
Right. Okay.
Unless you're changing the pressure. Yeah.
Okay.
Okay. So he's saying my uncertain. So this is his data. I have no idea where he got this. Where he got this Venus
So the
data.
only place I could think that he would be getting Venusian like temperature data would be like
Yeah.
returns from the Venera probe.
Yeah.
Which, I mean, okay, I guess but as far as I know, we don't have any other sources for like the temperature at different heights or pressures from Venus.
Yeah.
So the only thing I could think of is that, I mean, so I don't know. Does anyone know if the Venera probe had like a temperature and pressure sensor? I imagine it probably did.
I feel like I can Google this. Venera
I believe so.
probe.
Maybe instruments.
Yeah. Gamma ray spectrometer. Okay, that's fine. UV grating monitor electron proton.
None of that is just a thermometer or like a pressure sensor.
Okay, so let's actually just go to like Venus temperature profile.
Savage Cobra official says not to be confused with the venereal probe.
Right.
I was actually going to say, we could replace Venusian with venereal. They mean the
Venereal,
same thing technically.
Yeah. Okay. Okay.
It's weird how the picture that NASA showed us had clouds and not no atmosphere. More NASA lies.
Yeah, NASA lies, clearly. Yeah,
so less pressure than at the Titanic.
Less pressure than I thought I saw that they did. Oh, you know what? I bet they did. Hold on. This. I wanted to see this. I bet they just did adiabatic. Okay. Oh, European Space Agency. There we go. Can you guys see what? Yes. Okay. I was like, am I just looking at my screen and no one can see what I'm doing? Okay. Fun fact. Venus and Earth have roughly the same mass of carbon on both planets, but on Earth it's in things that are alive and also rocks, and on Venus it's like all in the atmosphere.
And humans are trying to push Earth to be like Venus.
Yeah.
Well, okay, not so much with the rock carbon, but with everything else.
Oh, okay. This is I'm trying. Venus Express made the measurement. Okay, so this is from Venus Express. Which,
so, by the way, Vagary is pointing out Russia landed probes. I think, as far as I know, only one probe, but that was the Venera probe that we were mentioning.
Yeah.
Venera was a Soviet probe.
Okay.
Which in some ways means Kazakhstan landed a probe on Venus.
Yeah.
Because that's where they launched from.
Okay, so this is looking at day side versus night side. KB said, "Good God, is that rain?" Can you guys hear the thunder in the background?
I've heard it a few times.
Yeah, welcome to Oklahoma in the late spring, early summer.
You're not gonna have a tornado, are you?
Probably not. Let's look. Weather.gov. Let's see. I am under just a severe thunderstorm watch. I feel like that should maybe be escalated. And let's go to the radar, shall we? Hey, that's me. That's that storm system. You guys are here.
Yay!
Yay! Are you gonna let me zoom? Are you gonna let me go to my region? Anywho. Oh, hey, Venus Express was a European Space Agency mission that launched out of Kazakhstan in 2005. Awesome.
Nice. Where did the ESA launch out of Kazakhstan and not, was it French Guiana. Isn't that where the ESA usually launches? It's French Guiana?
I don't know enough about... I stopped doing planetary science to do weather.
That's fair.
Anywho.
Which is also a kind of planetary science if you think about it.
It's just a specific part of a specific planet.
Yeah. Although I imagine that Earth atmospheric science would be applicable to other planets in some ways.
Mm-hmm. Like Jupiter, super cool in that specifically it spins really fast, whereas
like 10 or 11 hours a day.
Yeah, so Earth is a slow rotating body. Hey guys, if you were wondering where I'm living, it's here.
Oh, fun.
Yeah. Anywho. Okay. Maybe that'll like break the heat though. Okay. Oh, right. We were looking at this temperature profile. Okay. So I am really flying through this, but this looks like the profile that was known before the Venus Express, and then that's like Venus versus Earth, and then I think that's supposed to be maybe what the temperature. So this is, this is temperature on the x-axis. So as you move left, you're getting colder, and then on the y-axis is altitude. So this is Venus nighttime temperatures. Okay. So let's look at, let's just look at this. Okay. So so this is, I can tell you how they make this profile. This isn't measured. This should be, I'm guessing, adiabatic. So which is just like, if we know the surface temperature, or it's like maybe they had like 5 points of data and linearly connected them. That's kind of what it looks like to me. Right, because this looks like we have a data point here, 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 here. And then just drew lines in between. Okay, I bet that's what they did.
Well, then I would say as long as he's using an actual model that NASA published, which I'm guessing is the case, those numbers are probably reasonably accurate.
Yeah, that seems pretty reasonable. And yes, he's saying he's reading this off a graph. Okay, so that's fair. Like, I'll give that to you. And notice like the error, which I'm going to be assuming is the difference between the temperature, like between this and this. Yeah. So this is his like standard atmosphere here on planet Earth. And there is going to be like Venus standard atmosphere. And then, so standard atmosphere, by the way, that's just like, if you want to talk like we're not super interested in the actual weather. We want to think about what is an average boring day look like at any given point on planet Earth, right? That's kind of the idea of a standard atmosphere. And then this is the temperature of Venus divided by that ratio he calculated here.
Yeah, so that's his predicted temperature for Earth, according to his model.
Right. And so then this is how far off his model is, which notice we're off by like, right at 1000 millibars, it's off by half a degree. Sure, that could be, error off of reading off a graph, but like 5 Kelvin, 4.5, right? Like,
I mean, you can also call it 5 degrees because the unit scale in Kelvin and Celsius are going to be the same scale.
Yeah.
An increase of 1 Kelvin is the same amount of change as 1 degree Celsius.
Yeah. So the fact that it like happens to fit really well at, honestly, specifically 900 millibars, right? But doesn't fit well elsewhere.
Yeah.
Okay. Okay. So let's keep going on. So he's talking about his uncertainty in this paragraph, and let's go to his explanation for that uncertainty. The Venus atmosphere is 96.5% carbon dioxide and supposedly superheated due to the runaway greenhouse effect. Yet, that portion of it within the pressure bounds of the Earth atmosphere is remarkably like Earth in temperature. This is student-level analysis and could not have been neglected by the climate scientists if they were not rendered incompetent by their dogmatic belief in the greenhouse hypothesis. Earth atmosphere doesn't stop at 200 millibars, friend. It goes to 0. So what does that look like if you keep extending? 2, there's error bars here, right? Like there's error bars not just from your ability to read the graph, but for how those were calculated, right? So what are those error bars?
No, see, Maddie, physicists don't have to worry about error bars.
Oh, my bad.
And he's a physicist, so we don't have to worry about error bars.
He's a physicist.
Yeah.
Okay.
Physics measurements and calculations are always accurate to infinite decimal points, infinite sig figs.
Mm-hmm.
That's how physics works.
That's how physics works. Also, how do you get to the surface temperature, right, of 900 Fahrenheit or 475 Celsius, right?
Yeah, it seems like it would have to be because the atmosphere is trapping some heat or something.
Right, and here's the thing. When he did that black body calculation, that is the surface temperature if there is no atmosphere.
Yep.
Okay.
Yep. So he's starting out with assume there's no atmosphere.
Right.
Now that there's an atmosphere, let me tell you how my assumption that there's no atmosphere proves that the atmosphere doesn't trap heat, I guess.
Yeah, exactly.
Okay, sure. I guess you could do that.
Yeah. Okay. Again, the overwhelming extent of fundamental incompetence exhibited by science today is the real underlying story. This result also flies in the face of those who say the clouds of Venus reflect much of the incident solar radiation, and that therefore it cannot get 1.91 times the power per unit area received by the Earth. The direct evidence presented here is that its atmosphere does, in fact, get that amount of power, remarkably closely.
Maddie, can we actually check the albedo of Venus?
Yeah. What is Venus albedo?
Because I'll bet it's higher than 0.3.
Albedo. 0.7.
0.7? My goodness.
0.7.
That is huge.
That's huge.
That definitely dwarfs the 1.7 or what was it, 1.17 or whatever it is.
Yeah, the 1.19. So
1.19. Yeah, that is my guy. You can't ignore a 0.3 versus a 0.7 albedo. Come on.
Okay.
That means that Venus reflects more than twice as much of the light that hits it compared to Earth. That is ridiculous.
It is. So okay. Here we go. Okay, so
0.7. I was not expecting it to be that high, honestly.
Gray bodies. No, I want to do. Okay, so black body equation with albedo. Just IB physics. Yeah. What is the? I need to be able to connect my iPad to these streams so I can just write out the equations that I'm thinking of. Yeah, that'd be really handy. So when you're doing this black body calculation, right? Also Savage Cobra, official per se. According to Wikipedia, most if not all of the Venus probes carried thermal sensors. So I hope that they were taking temperature readings as they descended to get that vertical profile. So maybe he's getting that. That would be great.
Also, Vagary said Venus is the second brightest body in Earth's night sky. I feel night sky. Okay, I was
Night
gonna
sky.
say I feel like it's the third brightest after the sun and the moon, but then if we go with night sky, then yeah, I guess it would have to be
Yeah.
after the moon.
So when you're okay, let me go back up to where he's like talking about black body radiation. Maybe just Boltzmann's law. Just show me. Yeah, here we go. Okay. So, friends, Romans, countrymen.
Are you saying Boltzmann law includes albedo as one of the actual factors in there?
Yeah, so he was doing this just as this is S naught here is the solar constant. This is how much energy does the sun make total, right? And then it's divided by 4 times sigma, which is the Stefan-Boltzmann constant, and then the fourth root gives you the temperature of the like body. You've got to do the like you've got to then figure out how. So this is going to be how much energy, right, is being emitted, and then you do have to address like distance from the body and
right,
like cross section. How much of that are you absorbing, right?
Can we double check to see if he actually did use albedo in his calculation? Because I don't remember it being there, but
he didn't. He hasn't mentioned albedo.
Well, can we check because he gave us the math that he used? Is it up near the top? Let's see.
You should have a calculator within. Yes, I've got a calculator within Grasp.
Okay, so let's see. Okay. Where's his use of Boltzmann law?
Okay, here.
Nope, he's just using the difference in the distance.
Yeah, it's just the difference in the distance and not accounting for the fact. So it is true that this ratio of like the amount of solar energy that hits the top of the atmosphere is 1.91 times the power per unit area, right?
Yeah, but more than twice as much of that gets bounced back off by Venus as compared to Earth.
As compared to Earth.
So his actual ratio should be significantly lower.
Yeah. So should the ratio be this number times the ratio of albedo?
Yeah, that should work out.
That should work out. So it should be, instead of 1.91, it should be, and he's doing Earth distance over Venus distance. Okay, so it's 1.91 times, and then, so Earth albedo, except you've got to flip it, because it's 1 minus albedo is what goes into the equation. Right, so it should be over 0.7 over 0.3. It's dangerous to do math live.
Yes.
So I get 4.46.
Well, so here's an idea. Let's try actually just doing out the whole Boltzmann's law, right?
Yeah.
So okay. we'll so can you go back to the page where there was a Boltzmann's law?
Yeah.
All right. So what we'll do is we'll say, okay, we'll hold S sub 0 or S naught as just Earth, right? So okay. we can basically ignore the 4 sigma because it's just a factor. So, and all we want to know is the relative ratios. So we can ignore that because it's not going to change.
Right.
So if we say that, so the, where's my stupid phone that has my fancy calculator? Did I leave it in the other room like an idiot? You have your calculator, right?
I've got my calculator.
All right, so let's do 1 times the sum of 1 minus 0.3 and put that find the cube root of that number.
The fourth root of that number?
Fourth root of that. Sorry, yeah, fourth root.
So just the fourth root of 0.7?
Yeah, basically.
Okay. Okay, that's 0.91.
All right, so let's put that down somewhere, 0.91. Okay. Mm-hmm. So then his ratio of solar incident was about right. So we can use the 1.9.
Yeah.
Was it 1.91? Was that what it was?
1.91. Yeah.
Okay. So 1.91 times.
Oh, wait. No, because he does. It's the fourth root of 1.91.
Right, but we're already doing the fourth root now, so we
Okay.
need to use the 1.91 as our S naught.
Okay, fair.
Okay, so we do 1.91 times the fourth root of the total 1.91 times 1 minus 0.7, or times 0.3.
Yeah. Okay. So 1.91 times 0.3 raised to the fourth root.
Wait, no, don't raise it.
No, sorry, I raised it to the 0.25. It's easier to do on the calculator.
Got it.
Yeah. So that's 0.87.
Okay. What's the ratio between those two?
Okay. Like
because
1.
remember, okay. So
Yeah.
according to Boltzmann's law, Earth and
Yeah.
Venus should be exactly the same temperature, buddy.
Yeah. That's really funny. That's really funny.
I used Boltzmann's law, except I ignored one of the terms. Oh,
Yeah.
Good job. Good job, physicist.
Yeah.
What the hell?
That's really funny.
And that wasn't even that hard to do. That was high school level math, right?
Yeah. Oh my goodness.
Wow.
I like Vagary's comment here. Maybe the fact that it's a simply student's calculation might indicate you're missing bits.
Yeah.
Maybe. My gosh.
I love this. We're going to ignore not only the atmosphere that exists, which complicates this, means you can't just straight up use Boltzmann's law, but then on top of that, we're just going to ignore one of the important terms in Boltzmann's law, which completely changes the prediction to basically mean that, hey, if all that matters is Boltzmann's law, which is what you're saying, buddy, Earth and Venus should be the same temperature. Now, Maddie, I know we said earlier, they said they should be the same temperature at the same level of pressure. We'll give them that, right?
Yeah.
So can we scroll back up to his comparisons?
Mm-hmm.
Now, remind me, is 287.4 Kelvin roughly the same temperature as 338.6 Kelvin?
Not even a little bit.
No. In fact, I feel like I would notice, if I were in those temperatures, very significant differences.
Mm-hmm.
I feel like one will be reasonably comfortable,
mm-hmm.
and the other one would be fatal.
Yeah.
Okay.
Fatal's the word you're looking for there.
Got
Absolutely.
it. Okay.
Yeah.
Just wanted to make sure.
Yeah.
Weird that.
Weird that. Yeah. Let's see. 287. You might. That's like 15 Celsius. You might want a jacket. Might want a little cardigan.
I'm mesothermic. I can kind of hack it.
Okay.
Oh, there's an update. Good.
There's an update. Hold on. We haven't. So this result also flies in the face of those who say the clouds of Venus reflect much of the incident solar radiation, and that therefore it cannot get 1.91 times the power per unit area received by Earth. By the way, this isn't those who say. Albedo is a thing you can literally like measure, right? If you can see it and you're like, how shiny is it? You can measure that. Like, anyway.
The moon has about the same albedo as coal.
Yeah.
Which is crazy to me. Like, if you had a piece of moon in front of you, it would just look black. It's about as black as like a slate blackboard that you write on with chalk.
Yeah.
It only looks bright because it's in contrast to much darker surroundings, like, the blackness of space.
Yeah. Okay. This, in fact, indicates that the Venusian atmosphere is heated mainly by incident infrared radiation from the sun. Full stop.
Well, yeah.
No.
But why does it stay that hot?
No. Dapper, that's the greenhouse effect. Because that's what he was describing. Because a mostly CO2 atmosphere is going to be like, it's going to be fully transparent to incoming solar radiation, right? So that incoming solar radiation comes into the surface, and then the surface reflects that up, so that the fact that the atmosphere is warm, right, is the greenhouse effect.
Mm-hmm. Venus is only warm because of the greenhouse effect that I say doesn't exist, because I proved it using the planet that most famously has a runaway greenhouse.
Exactly.
We're right back into like, hey, this Boeing 747 proves that heavier than air travel is impossible.
Yeah.
Okay.
Which is not reflected but absorbed by Venus's clouds. Again, that's the greenhouse effect.
What is this?
Oh, he's saying rather than by warming first the planetary surface. So he's saying that no, CO2 absorbs in light and UV, not in infrared?
I don't know.
It also indicates that the Earth's atmosphere is substantially warmed the same way during daylight hours by direct solar infrared irradiation. Common sense disproves this. If this was true, then the hottest part of the day would be at noon when the sun is overhead, right? And we all know that that's not true. The hottest part of the day is like at 3 or 4 p.m.
Yeah.
Right.
I know that for sure.
Yeah. This also means that once the sun sets, overnight temperatures would be constant, right?
Mm-hmm.
Because right, like because we turned off the source, right? So then the atmosphere would immediately lose everything, right? But that's not true, right? Like you have like the Earth holding on to energy. So that's just common sense. And that the temperature profile or lapse rate for any planetary atmosphere is relatively oblivious to how the atmosphere is heated, whether from above or below. Well, that's nonsense.
If that were true, then wouldn't every atmosphere have about the same like shape of its lapse rate? But we know that that's not the case.
Yeah. Can I like draw a picture?
Well, I mean, if we look at the Venus and Earth comparison in the lapse rates,
yeah,
they obviously don't have the same shape. So
yeah. So hey, team. Okay, no, I need to draw. I need to like a Microsoft Paint. I need Paint.
You could probably pull up Paint as a program and then just change to presenting that window.
I have a Mac.
Well, there's your problem.
Right, that right there is my problem. Okay, team. This is the ground. Look at it in all its glory.
Wow.
Yeah, is good.
I can see my house from up here.
Yeah, I accidentally made some topography. It's fine. We've got a sun. It's happy.
This is to scale or not to scale?
To scale, obviously.
Oh, wow. I'm impressed.
Right, clearly.
Earth seems to have gotten a lot closer to the sun, but that's okay.
That's fine. Okay, so let's imagine that this is our temperature profile. Okay, so I'm trying to draw a straight line. Imagine Earth's temperature is just constant up and down. Right?
I feel like I should point out that MS Paint has a straight line tool.
Listen. Don't confuse me with the facts, Dapper. This is better. Okay.
This is way better.
This is way better.
Got it.
If we were heated from above, right, and that was the only thing going on, then we would expect, so imagine like this is what happens overnight. Temperature profile kind of evens out, right? And then the sun comes up. So if we were heated from the top, then we would expect that profile, warm is to the right. Temperature increases to the right.
Got it.
Okay. Then we would expect the top part to warm up first. So as the day goes on, right, we would expect roughly that shape, right?
Mm-hmm.
And it would take a long time for the surface to realize that the sun was up.
Which should mean that on average, like the top of Mount Everest should be warmer than the base of Mount Everest.
Yeah.
Okay.
Well, no, because Deborah, because that's getting into temperature pressure relationships.
Ah.
Right, that's getting into the adiabatic. So like we won't worry about that. But if this is what we look like overnight, the air column kind of evened out, right? Well, actually, for the science nerds out there, we'll say that this is potential temperature, because potential temperature is temperature ignoring adiabatic effects. So, Dapper, in your explanation, the potential temperature on the top of Mount Everest would, on average, be warmer than the potential temperature at the surface.
Is that how it is in real life?
No.
Oh, weird.
Right. And then, or we would see, hey, it's warming like this, and then it goes like that.
Now that one that you just showed looks more like what I remember from the NASA website for Earth.
Uh-huh. Yeah, this is what temperature profiles look like. We start to warm up, right? And then we're like, these are little convecting cells, and it pushes this higher up. This little point, right, moves up. It's trying to make the whole column warmer, right? As we're mixing warm. So we're heated from the bottom up. Good God. There are some weird things in the stratosphere. So the stratosphere is characterized by, it has a lot of ozone, O3. And so in the stratosphere, temperature actually increases with height. It doesn't decrease with height like you would expect. But that's actually because ozone absorbs in the UV. So the stratosphere is like opaque to parts of incoming solar radiation. So the stratosphere is absorbing energy directly absorbing solar energy. And we find that temperature increases with height, right? We find the left profile, as opposed to generally decreasing with height, as we find in the right profile.
Okay, but Maddie, have you considered that everything you've learned at school was actually a satanic conspiracy to cut into the profits of petrochemical companies? Because I feel like you haven't considered that possibility.
I was going to do this really fun. I'm going to try to do this fast. Is that Washington State? I'm not going to be able to do this fast. Ugh. Okay. Sorry, there's a university that keeps a map of the U.S. and they've got clickable every Rayonson profile. Those are launched 2 times a day from every National Weather Center station, right? And so where do we get that data from? What is that? It is National Weather Service Rayonson data. Thank you. Data. Oh, why do you want to use my location right now? Not right now.
Because it wants you to show you the data from where you are.
Probably.
It's trying to be helpful.
It's trying to be helpful, but it doesn't know what I want.
No.
That's the little instrument that gets launched, by the way. It's a Rayonson.
And that goes up on a balloon? Yep. That's a balloon.
If you find one, follow the instructions to return it.
What if I want it? Like, what if I want it to be mine now?
I mean,
Like
just don't tell anybody.
Okay. Like, if a balloon lands in my yard or something, do I have to give it back? Is there a rule?
I mean, you're kind of supposed to.
But, like, would I get in trouble if it came out that I didn't?
Probably not.
Okay.
They can't be. They can't really be reused. Why are you not?
Fakery says, what if I find a shot down Chinese weather balloon? That's a good question. You should probably tell someone about that in that case, because might not be a weather balloon. While Maddie's looking up that, my favorite thing with the Chinese cover story that it's a weather balloon per this like international treaty that allows us to send weather balloons pretty much anywhere in the world, which is true. But that treaty also defines like how heavy a weather balloon can be for the purposes of the treaty, and it's pretty small. And like you look at that weather balloon, the Chinese balloon's payload, and it's just like a gigantic mass of like steel girders, and you're like, I feel like this is over like the half a kilo or whatever it is weight limit for weather balloons. Just guessing.
Sorry, there's the actual raw data. It was University of Wyoming, not Washington. My bad.
Well, here's the thing about Wyoming. It basically has no reason to exist, so that's why everyone forgets about it.
Yeah.
Have you heard about the conspiracy theory that Wyoming doesn't actually exist?
Ooh, only about North Dakota.
Well, there's one about Wyoming because here's the thing, right? Like, when was the last time you actually met someone who was from Wyoming?
College. I went to college with a girl from Wyoming.
Well, most people haven't because it's by far the least populous state.
I did it.
There it is.
Yeah, my year, she was the... No, okay. So my year at MIT, there was no one from Wyoming. And in her year, she was the only one.
Yeah, that makes sense.
Yeah. Okay. This is called a skew T-plot. I was in the middle of explaining this on my Weather 101 series on my show when I got too pregnant to continue. And, okay. So, this should be... Yeah, so this is like today. This is actually the sounding from my area.
Nice.
Yeah, OUN, Norman. So this should be temperature, and then this should be dew point. So the one on the right is temperature, the one on the left is dew point, and this goes basically through the troposphere. Actually, this is the tropopause right here, where we switch from the troposphere to the stratosphere. And the reason I can tell is because we have this sharp pivot where all of a sudden we start warming with height. So that's what the ad is. But notice, in general, temperature decreases with height. So we can't be warming from up here, because then we would increase with height. We're decreasing with height. Ugh. The end. That's what I wanted to show you. It's very, like, you can just go look at data and disprove this nonsense. This is his, like, I have a hypothesis, and I'm going to go literally no further. Yeah. Oh, gosh, it's 9:20. I meant for us to take a break, like, at 9, but I got too mad.
That'll happen.
It happens sometimes. So I say we try to read to the end of this, because it's almost done.
Okay.
And then we can call it... Okay. So, all right. Okay. So he's talking about that, like, this is nonsense. Okay. This has already been pointed out recently by physicist Gerlich and other name I can't pronounce. Dapper, you want to give that one a shot?
No.
Okay, cool. Who have written succinctly.
Seuchner? Seuchner? I'm gonna go with Seuchner.
Since the Venusian atmosphere is opaque to visible light, yes, that's opaque to visible light. That means that it's reflecting that a high albedo. Wait.
Well, now, real quick, remind me, Maddie. If visible light hits something that's, say, black in color, therefore has a very, very, very low albedo,
yeah,
that energy just disappears from the universe, right?
Yes, just disappears from the universe.
Okay. It doesn't get converted into like thermal energy, which then heats up that object or anything?
No, not at all.
Oh, okay.
So this is, since the Venusian atmosphere is opaque to visible light, in the atmospheric science parlance, that is fully not true. It is not opaque to visible light, because opaque would mean that the atmosphere absorbs specifically in the visible range, absorbs and emits, right? But it doesn't.
Right. Plus, hey, here's this cool thing.
Yeah.
When Venera touched down on the surface of Venus, it was able to take pictures because it wasn't pitch black.
Mm-hmm.
And it was using visible light cameras. So, yeah.
Yeah. Okay, so this is on barometric formulas and their deviation from hydrodynamics and thermodynamics in this Institute for Math and Physics. Look at me, willy-nilly translating German to English.
Yeah.
Yeah.
Ooh, it's from Hamburg.
Hamburg. So this is, we derive the approximate pressure profiles, density profiles, and temperature profiles of an atmosphere, also called barometric formulas. Cool. Our variant of a derivation goes beyond the common standard exercise of a thermodynamics lecture, where commonly the discussion of the underlying physical assumptions is missed. We depart from Navier-Stokes equation and explicitly point our attention to physical assumptions disregarded elsewhere. This might be fun, actually, to read through on another stream. Anyway, but we'll go back to this guy. Okay. Yet they are ridiculed by climate scientists who thus behave like spoiled children who refuse to be chastised by their parents. First of all, I do not get paid enough as a graduate student to be considered spoiled. Thank you. Second of all, physicists are not the parents of other scientists.
Especially physicists who would just ignore important terms in, the equations they're using.
Yeah.
So can I just point out,
please,
as a general rule, if you find yourself in the position where you think that all of the world's experts on a topic who have spent decades of their lives dedicated to one specific study have missed some obvious thing that you have discovered by watching YouTube videos or something, there's a fair chance that you're wrong that they haven't considered that thing. Just putting it out there. I noticed that his in here we don't have a whole lot of alpha for albedo, which is weird.
We don't. So this is him. Apparently, his update. People got mad. People pointed out that he wasn't corrected for albedo. And right. So his fact that he ignored albedo
thoroughly hindered the acceptance
of my analysis.
You don't say.
My initial approach to the problem was in fact sound, even if too simple-minded for most. That sounds like a self-own.
Yeah. So here's the thing, man. When we ran your numbers, but with albedo, we came to basically a ratio of 1, meaning that according to your model, once we stop ignoring albedo, Earth and Venus should have the exact same temperature at the exact same pressure, which they don't. Not even close.
So from Vagary, those two German authors seem to have a chip on their shoulder about climate science, judging by their listing of works. They might be fun to read through, actually. They claim atmospheric heat pumps don't exist, so that's fun.
I'll be honest, if you had said to me, hey, Dapper, do atmospheric heat pumps exist? I would have said, maybe?
Maybe? Yeah. Oh my gosh. Okay. So let's keep, oh my gosh. Okay. My above initial interpretation is quite correct, and in fact unavoidable, although it is not a complete statement. The complete interpretation, which I have stressed as a logical fact ever since, both in comments below this article and on other internet sites, is that the two atmospheres must directly absorb the same fraction of the incident solar radiation.
No, that's what albedo is.
That's what albedo is.
Holy crap. Earth absorbs more than twice as much.
Yeah. Jeez.
What the? I'm trying not to curse too much on your Christian Minecraft server here, Maddie.
Minecraft server, but here we are.
Holy shit, dude. Oh my god, I hate it so much.
I hate it. I hate it. I hate it. Because look. Supposing that both atmospheres do absorb and are solely warmed by the same fraction F, but the point is that F is not the same. And given the ratio of the two planets' distances from the sun, the governing formula for the Earth and Venus atmospheres in turn, so this F should be, which he's saying is 1, right? This should be like the 0.7 over 0.3, right?
Mm-hmm.
Like,
no, I feel like 0.7 over 0.3 is significantly less than just 1. Uh-huh.
Yeah.
Weird.
Because oh my gosh. Because they don't absorb the same fraction. This result is independent from the fraction F absorbed. Because you divided out F, assuming it was the same.
Oh my god. Okay, I'm calling it right now. This guy is not a physicist.
He's not. There's no way.
No. Look, I'm not a physicist, but like I've done some physics here and there, and I already know that this is completely inappropriate.
Yeah. Oh my god. Dapper, what he's saying, if I read forward a little bit, what he thinks is happening is because some of his numbers kind of lined up, that means F must be 1.
Oh my god.
Oh my god.
I don't even know what to say to that.
I don't know what to say to that. That's like the heat problem isn't real because there's no evidence of a heat problem in the rocks.
Yes, it is. Like my guy, albedo is directly measured. It's not a mystery.
It's not. It's not a mystery. It's directly measured. We know the difference. And he's like, no.
And 0.7 to 0.3. Not a minor difference, my dude. That's a very significant difference.
Yeah.
Because remember,
oh my god,
it's physically like impossible for albedo to go below 0 or above 1 because that would violate the first law of thermodynamics, right?
Mm-hmm.
So 0 to 1 encompasses the entire physically possible range of albedos. 0.3 is way over at one end, and 0.7 is way over near the other end. That's pretty significant. My goodness. This is... Maddie, this is your revenge for me showing you things like Matt Powell, isn't it?
It is. It is.
That's fair. That's fair. I get it. 212 comments.
And again, my favorite part about this is, why is Mercury not warmer than Venus? He never brought up Mercury. He just keeps saying, my data is right, and he says that in like 5 different ways.
Yeah.
Yeah. That.
Which, I mean, cool, buddy. But
cool story, bro.
I loved it. Direct measurements of albedo refute him.
Yeah. Direct
measurements of the temperature of Mercury defeat this.
Yeah.
The fact that greenhouses exist at all as a thing that people build also refute this. Mm-hmm. But also, just doing any old, study involving any of the greenhouse gases in a lab where you can just also directly measure the greenhouse effect of those gases also defeats this. And he's like, yeah, but when I did some cherry-picked math, the numbers lined up.
Cherry-picked math.
Yep.
Where he did not tell us where he got that profile from.
Yeah, that's another thing. Man, if you're a physicist, if you're an actual publishing physicist, you should know how to cite your sources.
Yeah, I'm gonna...
Yeah, I do not believe for a second that this guy's a physicist. Here's what I think. I think this is a guy who got like a physics degree as like a bachelor's degree,
Yeah.
which I'm not in any way denigrating that, right?
Right.
But then has like a job at like, I don't know, like some company where he is like middle management or something, right? They just cared that he had a degree. That's it. That's all they cared about. And he's like, well, since my degree is in physics, I'm a physicist, which would be like me saying I'm a historian. Why? Well, because I have an undergrad degree in history. That doesn't make me a historian, guys.
Right.
It makes me some schmo with a degree in history that's a bachelor's degree. I'm not publishing in the field of history. I guarantee you that with this level of work, this guy is not publishing in physics journals.
Yeah. Okay, I actually did find his source.
Oh,
It's hold on. It is Shade Tree Physics.
The heck is that?
What? Yeah.
Can we like get rid of all the stuff after the .com? Just see what Shade Tree Physics is overall.
Yeah.
This 90s level web design is not inspiring confidence.
It does not inspire confidence.
Oh, you want to put Newton back in physics? This sounds like some like Einstein crap.
Yeah. Click star map. Fun stuff,
goodness.
serious stuff, low.
Oh.
As you can see from my resume.
Wait, or if you click resume, does it bring you back to like where you were in the web ring? No, it's a resume. Okay.
Oh no, Civil Air Patrol.
Look, nothing wrong with Civil Air
There's
Patrol.
nothing wrong with Civil Air Patrol. Okay.
Telecom specialist. There you go.
Okay. Listen, there's nothing. He's got a BS in electrical engineering. Nothing wrong with that. That's a great thing. But if
that doesn't make you a physicist.
Yeah.
That actually less makes you a physicist than what I said, which was that he had an undergrad degree in physics.
Yeah.
Oh my goodness, Velikovsky. You know who Velikovsky is, right?
I don't.
He's the one who thinks that Earth used to orbit Jupiter.
Oh.
Yeah. Yeah.
Oh no. He's trying to connect the flu outbreak of 1918 to Venus?
Top tier source, my guy. Just chef's kiss. The sunlight filtered through Venus and gave everyone the flu.
Oh no! We go back. Oh wait, no, I have to go on forward. Here we go. Okay.
Oh my goodness.
So this is Magellan Orbit 3213. Okay.
I wasn't expecting it to get this bad, Maddie. I'll be honest with you.
I wasn't either.
We got a Velikovsky in here.
Yeah.
Oh my goodness. Oh, Velikovsky is also one of those guys who thinks that like there's a Nibiru planet that sweeps through the inner solar system every like few thousand years. Yeah. You ever read the Dragon Riders of Pern series?
Yes.
Yeah. The Nibiru is kind of like the planet that sweeps through the Pern system every once in a while and brings the thread. Horrible things happen every few thousand years, except I guess in Pern it was like, what, every 150 years and it lasted for 50 years or something?
Yeah.
Yeah, guys, by the way, in case you didn't know, I'm a giant nerd.
We are both giant nerds. Okay. We did, however, get back to the European Space Agency.
Well, I mean, I'm glad that this crazy thing cites something that's reasonable, because I mean, those lines do look like this green line, right?
Yeah, these do look like lines. But that's our friend's source here. So that's great.
Wow.
That's good.
Do you think he would stand by that website's endorsement of Velikovsky?
I don't know. I would like to find out.
Yeah.
Oh, that's the weird one.
I'm almost tempted to leave a comment, although he said the comments
are closed.
But he has another place where you can leave comments, because he said instead leave comments here. So, because my goodness, Velikovsky is just absolute bonkers nonsense. Like doesn't stand up to the first level of scrutiny.
Yeah. That's amazing.
Yeah.
Well, team, I'm not gonna lie. I'm about to die of heat stroke.
Well, don't do that. But also, are you sweating right now?
Yes.
Then you're not about to die of heat stroke.
That's true. That's true.
Okay.
I was being dramatic for emphasis because.
All right. Well, as someone who's had heat exhaustion that was inching that way, I take it a little seriously.
I have had proper heat exhaustion before. I was a kid and I just didn't drink enough water and we went hiking.
Oh, did I tell you about my mom in Phoenix?
No.
Okay, so Phoenix has some great botanical gardens, right? The Phoenix Botanical Gardens are great. And my adoptive human parents were in town. And I was like, we should go to the Phoenix Botanical Gardens. Because, they're really nice, right? And it was the right time of year to go because a lot of the cacti are in bloom and they have a really nice, butterfly enclosure and whatnot. Okay. So we get there, we buy some water, just water bottles, right? And they have little fountains all around the garden so you can refill your water bottle. So, me and my dad, we're sipping water and we're not really, watching my mom drink her water because she's not a baby.
Right. She is, in fact, a grown-up.
Right. So we get to the point where we finished our water and we've gone through the little butterfly garden and we get to our first little refill station. And we're like, okay, let's refill. And then my dad turns to my mom. He's like, hey, let me refill your water bottle. She says, no, I'm fine. And we're both like, wait, what? And we look back at her water bottle and it's almost completely full. And we're like, we've been at this for a half an hour in the summer in Phoenix. So we pull her aside to the shade and we're like, you have to drink this bottle of water.
Yeah.
Right now. And as she's doing it, she's like, oh, I'm starting to feel a little lightheaded. Yeah, man. Yeah. It's 120 degrees out Fahrenheit and you haven't had a drop of water. So we made her finish that bottle of water, went and refilled it, made her finish another half bottle of water, and then we continued on with our day. But oh my goodness, Mom, come on.
Yeah. So, okay. When I was in my fork and knife school of officer training.
Right.
Because for you guys that don't know, I got to go to not even regular officer training, right? I got to go to the one where you commission before you show up, which is reserved for doctors and lawyers and physics teachers, and chaplains. So yeah, running at 4 a.m. in Rhode Island with a bunch of chaplains and psychiatrists, actually.
Interesting.
They got all the psychologists that were going to join the Navy that year were in my class. And that was actually kind of asinine because they thought they were allowed opinions. What are you doing? Absolutely not. But
not how the military works.
Not how the military works at all. So when we had a day where we got to save the Buttercup, which is a floating section of a ship in a pool and it's sinking and you have to save it. You have to prevent it from sinking. And so we're doing that. And since we had to go off site for that, we didn't go to the mess for lunch. And so we only got a piece of bread with a slice of American cheese on it. Right.
Those brown paper bag lunches.
Mm-hmm. And so we were all afternoon, up in chest deep, very cold water, right? Being very active, and doing that. And then by the time we got back, when we got out, my lips were fully blue. And when we got back, I was feeling really lightheaded. I was feeling I was about to pass out, and I was just trying to be chill until we got to go to dinner, right? But because it was ODS and it was all medical personnel, they were like, Maddie, you look like you're about to pass out. And I'm like, maybe a little. And then they called the nurse people there and they're like, how much water have you had today? And I'm like, I don't know. And then one of them had half a Subway sandwich in the fridge and they handed me that and a glass of water. And all of a sudden I didn't feel like I was about to die. And I was like, oh, And so they're like, okay, so eat a lot at dinner tonight. I was like, okay, I'm sorry. And drink more water. So I was like, I'm so sorry. The end. Anyway.
All right.
That's my opposite story where I got really cold. Apparently.
Yeah.
And dehydrated.
Hey, dehydration is serious. I remember when I had pneumonia.
Ooh.
I basically, we were in port and I wasn't on duty. So I basically spent the entire time just in my rack.
Yeah.
Doing night sweats constantly because I was awake for like 48 hours.
Yeah.
So the next day at muster, I just kind of collapsed and I was physically carried down to medical where I proceeded to soak up 4 full saline bags through an IV. And only on the 5th did I say, hey, I have to go to the bathroom.
Jeez.
Yeah.
Wow. That's impressive.
Yeah.
That's really impressive.
I was severely dehydrated.
You were.
That's why I went blind that day.
Jesus.
Yeah. More than once, actually.
That's not good. Okay, I had a young man who I was in charge of, because I was in charge of all of the officer students who were removed from the training pipeline, right? That was kind of like a secondary job of mine. And I had one young man who was removed because of medical reasons, because he was studying one day and all of a sudden was like, hey, I can't see out of my left eye now.
Oh. That's alarming.
That's alarming. And so like I would get calls from him frequently, like in the middle of the night. It was like, hey, I passed out again. My roommate found me. I'm like, cool. Call medical in the morning, because this happened like once a week.
Jeez.
He had played rugby a lot and had it was like one too many concussions. Right.
Oh, damn.
And that just sort of all caught up with him all at once.
Man,
but like,
rough.
That's really rough. So like on the one hand, that sucks. This is like a 22-year-old right out of college, right?
Yeah,
otherwise very healthy. But honestly, like, since that happened to him while he was in the Navy, right? While he was in his training pipeline, right? He just like reported to NNPTC, right? He just reported to us every morning, and I didn't even have a job for him to do, because I was like 50-50, you're going to pass out in the middle of the day.
Right.
So I just made him muster like 3 times a week, and otherwise please deal with your medical stuff.
Was he on like light limited duty?
Yeah. It was basically light limited duty, but like we literally didn't have a job for him to do. And so because he was in a training pipeline, you know, like the guys who failed out because of academics, like I made them do stuff, right?
Yeah,
they
like
had
go
to
clean something.
Go clean something. Go work in the mail room, right? Like we had a lot of them working in the mail room. I had some work for legal if they were going to be there for a long time, right? Like help out in legal. That was a great job for officer hold students.
File paperwork,
do it. But yeah, so like I do think on the one, like the silver lining I could find there was like at least he's like having access and like has medical insurance for right now, because he's on active duty, you know.
Oh yeah,
like he's going to be able to see all the specialists he needs to see, and like once that's figures out, he's going to be separated, right? But they're not going to. But till then, he's got a paycheck, he's got health insurance, and he can get himself figured out, you know?
Yeah.
So, if that was going to happen to him, unfortunately, that was a good time for it to happen to him, if that makes sense.
Definitely better than out in the fleet.
Yeah, that'd been bad. Can you imagine if he was on a submarine and was like on a boomer? I was like, I can't see out of my left eye now.
I mean, that wouldn't be good.
Go see our first class corpsman who's on board.
Yep. Mm-hmm. And then next time that we check in, maybe we can arrange for some kind of months.
In 3 months. Yeah.
Yeah. My goodness, that would not be great.
That'd be bad. Anyway, Navy. There's parts of it that suck.
Mm-hmm. There's
lots of parts of it that suck.
They don't not all the parts
Not all the parts.
but a lot of the parts.
Yeah. A lot of the parts of it suck. Anywho, hey, we're gonna wrap this up. So, team, for me, I'm gonna try to. This is technically the 4th Thursday of the month, but it's weird because the first of this, June 1st, was a Thursday. My thought is that I'm gonna try to do a debunk stream like the 3rd Thursday of the month. Which is that usually the same week we do we do Matt with Maddie? Or am I normally on the 2nd week?
So you're normally on the 3rd week.
On the 3rd week. Okay.
Yeah. So if we can,
Cool.
Yeah. So we could actually keep up that general pattern. Although, like weird week months like this month might throw it.
Yeah. Months like this are weird. But anyway, so like the idea thing is I'll have a debunk stream on here. With hopefully I can normally get a co-host. I want to thank Dapper. Thank you so much for coming on today. This was very fun.
I was.
I
never thought I would have this much fun ignoring Albedo.
Ignoring Albedo, right? So what do you got coming up on your channel? I saw your Hydroplate movie came out.
Yes,
okay. Sorry, the video you're responding to is terrible. I was about to say that incorrectly. It's so bad. Anyway, what else you got going?
So let's see. I will try to look ahead a week.
Okay.
So on the 24th, I am planning to just have another Dapper React. We're going to continue with the Dan Biddle speech that we started last week, where he used PaleoDB, one of his favorite websites, and then just used it very incorrectly and very obviously, while cutting off the legend so you don't actually know what you're looking at if you just look at his video. But of course, I'm familiar with the website, so I know what he's looking at, and I can tell you why he's lying about it. Then on the 27th, we were planning to have a Jackson with Jackson. And so Jackson will be on. We'll talk about Charles Jackson, Bad Jackson.
Bad Jackson, who, by the way, lives like an hour south of me.
Rough. You could run into him at like a Walmart or something.
I know, I'm against it.
And then on the 29th, we're going to be looking at part 1 of a 3-part series about, or it might be 4-part. Let me get back to you on that. Just 1 second. Let me double check. Yeah, 3-part series on Jeffrey Tompkins, who you might be familiar with from watching Erica's recent takedown of his numbers. Now, I'm not specifically talking about his ape-human genetic similarity comparison. He's done some other stuff, but I will touch on that a bit in an attempt to demonstrate that he is, in fact, as I titled him, the creationist who can't math. Because I've seen him in a published paper that he published on like the the ICR website, I think, fail to correctly add 2 3-digit whole numbers. Yep.
I'm very upset by this.
And this is the guy whose response to, hey, man, you have to weight your results to actually get a median value for your data set. His response to that was like, well, yeah, maybe if your N is 2, but my N was over 18,000. And it's like, okay. And? There was no follow-up. It was just, apparently there's some threshold where when your N value gets high enough, you just don't have to weight things anymore. I don't know where that is. I would love to know. Like, is it at 10? Is it at 1,000? I don't know. So yeah, that's what's coming up for the next week on my channel.
Awesome. Okay, well, thank you guys so much for joining this evening. I love seeing so many of you all here. So it's good to be back, and hopefully I will see you all in about a month. Okay, night, team.
Bye.
Bye.